Well, we made it all the way to the West Coast for the next edition of the Facades Plus All Things Facades live podcast. And welcome to our first guest. You made it actually from the East Coast as well. So welcome. Tell us what brings you here.
Definitely. So thank you so much for having me here. Basically, I just flew yesterday from Miami. My name is Alejandro Ballester. I'm the VP of projects for Neolith. Neolith is a Spanish company. So we manufacture all our sintered stone in the eastern coast of Spain, right in Castellón. Castellón is an area where the ceramics traditionally has been a great industry. So we were able to evolve, and from the ceramics knowledge, we created a long-standing product, which is called basically sintered stone, non-porous material, UV stable material. And even though we started being as a countertop company, we evolved as a solutions company. So right now we are developing the facades program where we not only sell the product, but also the entire system, shop drawings, installation, assistance, and so on and so forth.
So that's a huge leap. How do you what is the cultural reshift or reframe you need to go from an interiors-based company to facades, which, forget just the aesthetic, the performance element of it and dealing with the exterior elements and durability, versus something that you just have to deal with in the kitchen and some knocking around every now and then.
So it has been a learning curve, of course. And as we started in interiors and we saw that the product was performing very well with wine stains, the product was performing very well with heat of a pan or a pot. Suddenly, discussing with the architects and designers, because we've been talking with them a lot and getting feedback, they started asking us questions. So can we do it outside? What's going to happen when the sun faces the product for 5 years, 10 years? So we started doing a lot of R&D internally, and we ended up understanding that the product performs very, very well outdoors. So that's why we started try and error, and we ended up developing a new line of products. So for example, these ones that we have in here, these products are basically thought for exterior applications, for facades. And that's why the texture started to be a very important part of the design. And that's basically what we did. So we went all the way through, and we want to be a company that can provide solutions, not only for interiors, but also for outdoors.
So how, in terms of the texture, as you said, what happens when it's fresh out of the oven versus when it's exposed to the elements over time, and setting expectations early on with project teams that due to UV exposure and rainwater, that may evolve over time.
Yeah.
In a good way or a bad way, I don't know.
Yeah, definitely. So basically, the product is made 100% of natural raw materials. So we don't use any resins, any plastics. So it's basically clay, feldspars, and different natural pigments in order to give the different colors that we can provide. So basically, as everything is natural, when you expose to the elements, the product is not going to be affected, which means that the sun is not going to change the color. The water is not going to penetrate the body because it's 0.08% porosity. So basically, it's virtually a non-porous material. And the main reason why we achieve this is because we use a very, very precise industrial process, which relies on pressure and heat. So basically, the raw materials, they are pressed inside a kiln, very high temperatures, 1800 degrees. Then they cool down progressively, and that's why we get such a durable surface like this.
How then do you take it to, all right, so you have the confidence that the material will withstand the test of time and the elements, but in terms of engineering the system then to interact with the structure, interact with adjacent systems and interfaces, that must have been a learning curve and hard lessons learned, especially, would you supply something like this to a curtain wall contractor to integrate into a unitized assembly?
Definitely. And in fact, we've done that in the past. So when we are developing a project, we like to be involved early on in the design process, because based on our experience, we have seen and we have realized that the product can be used as a curtain wall, as you were describing. It can also be used as the exterior layer of a rain screen system. It can be bonded to the substrate. So we have several applications. Depending on the energy ratings that we want to achieve, depending on where are we going to assemble everything or how the construction is going to happen, we can go one route or the other. And basically what we do is we have a technical team in-house, architects, engineers, and even field technicians that will support during installation. And we've done a lot of calculations of the material. Do we groove it with one groove, two grooves, Kyle's anchor? So depending on the project itself and depending on the thickness of the product, we can go one route or another. And it has been, of course, a lot of different projects, trying, a lot of tests, NFPA 285, ICC certification, Florida product approval. We have mastered a system that we are very comfortable in every single state in the US.
So you talked about actually bonding the material either from a mechanical or technically a chemical, but chemical can be a form of mechanical means back to the structure. What is the preferred method to use, like epoxy or some type of mesh, or do you prefer some type of hook system? What's the preferred means of attachment?
So usually we have basically two options. When we are talking about a low-rise building, we can attach directly to the metallic profile with a structural adhesive. So we put the structural adhesive vertically in the profile and then we glue the panel. But then there's another option where what we do is we create two grooves on the back of the panel and then we insert a profile. This profile is going to be mechanically attached to the material and then we will hang it to a horizontal rail that will receive the loading of the panel. So basically, the StrongFix system, which is the one that we call with the grooves, is the one that we use for hospitals, schools, sports events, as the Chase Center that we did in Oakland here in California, because this gives an additional layer of protection, let's say, not only relying on a chemical solution, but also adding this mechanical component.
So does this change if it's acting as a primary weather barrier versus if you have some type of rain screen assembly that's designed to get water behind this? Does all of a sudden the performative requirements of this material change drastically?
So basically, usually when it's done as a rain screen system, we have the air barrier behind. So it's an open joint system where water can get in and will get in, and then it will evaporate and it will get out eventually. For the bonded application, of course, we need to be very, very conscious that the joints are going to be the weakest part because the material is not going to be porous. Water is not going to penetrate the material. But of course, the joints, we need to make sure that they are properly installed and we use the right material because these are going to be where water can get in. It's going to be much more complicated and we will need to do a remedial to fix if water gets in a bonded application. And that's why we recommend and we encourage the rain screen system because no matter if the water gets in, it's going to get out. So that's why we encourage to use the rain screen application.
So if you're working with a curtain wall contractor, what is their level of engagement or involvement in your facility to check quality control, and then vice versa, your level of involvement in theirs to make sure the installation is, in accordance with the guidelines?
Usually it goes case by case, so project by project. We like to be very, very engaged during the entire process, and we are proud of it because even though we rely a lot in our product, we want to be part of the entire construction sequence. So depending also on the manufacturer or the partner that we have for a curtain application, for example, either they will come to our factory, we will go to their factory, and we want to make sure that our product and their product, they laminate together using the right products and they perform together properly. So that's something that definitely we will and we are involved during the entire process.
Where can people go to see some of your favorite work personally? And this doesn't seem to be a geographically constrained or preferred product. It seems like it could be really anywhere. So from an aesthetic standpoint, where's your showcase area you like to show off the work?
So we are lucky because we have a few very outstanding and amazing facades that we've done worldwide. So for example, here in California, we have the Chase Arena. This one is a great example. That's the house of the Golden State Warriors. And we did that 6-7 years ago. It's still there looking great. So we are very proud of this building. We've done, for example, skyscrapers in New York. So this is also, it was a custom color that we designed specifically for the architect. And it's also very beautiful. And then, of course, in Spain, we've done a lot of different constructions. And in Asia Pacific too. So in Korea, we have an amazing partner that they use their own system with our product. They use not only 6mm, but also 3mm, which is basically 1/8 of an inch. So they have a specific way of attachment, which relies mostly on chemical attachment. And they've done in Seoul 25, 30 buildings, which are great. So definitely we try to showcase them. In the US, we've done hospital in Salt Lake City. We've done, or we are in the process of finalizing Ritz-Carlton residencies in South Florida, which is also a great project. And yeah, we've done a lot worldwide. Right now we are focusing a lot also in the Middle East because we have a great partner there, and we're trying to push more the facades. We've been working in the Middle East for interiors for years, but right now we are really pushing the facades there too.
So it looks like we're going to have to make a trip to Seoul, Korea to see some of this in action. Alejandro, thanks for coming on the podcast.
Definitely. Thank you so much.
All right, we got the next installment of the podcast now, and we have the RDH family here. And somehow I've flown from Boston to Seattle to LA, and I can't get away from you guys.
We're here. We're everywhere.
So apparently
Welcome to Boston.
Yeah.
West Coast, East Coast.
Yeah.
So welcome back. And I guess I'll start where you're in Boston. What is your footprint really here on the West Coast?
Our footprint here in the, well, Sasha could talk about that more in more detail. He's based in Oakland, but we've got offices from Seattle, Portland, Oakland. We've got presence here in LA and San Diego.
And the company started in Vancouver, which is also in West Coast, a different country, but essentially that's how it started, just moving southward.
Yeah.
Yeah.
So I would think, I originally thought RDH's hub was really in the Northeast and the Pacific Northwest, heating dominated climates. So when you travel 1,000 miles south of that home base here and you have very different facade constraints and performance criteria, does it require a different lens? I mean, I'm sure it's always performance driven, but you're solving very different challenges.
Yeah,
and
I
problems.
mean, Adrian, my role right now as a regional director for US East is to really grow that market all the way from Boston down to Miami. There's enough differentiation there, and so I'll speak through that lens. It's not only climate, but it is building practices. It is the skill set of the folks that are swinging hammers. And I was just telling somebody this morning, the biggest challenge for us. And I recognize this from my entire, the better part of my career, is connecting, sort of the PhD eggheads with the folks swinging hammers in the construction industry. What is so challenging in the construction industry? And there's very few connectors in between, and how you connect versus, say, the car industry, the automotive industry, where you've got eggheads designing cars, but you have a very clear structure on how to connect that to the folks that are actually building the cars, and increasingly more robots, right? So you have, you gotta, I use that analogy only to say, why are we struggling so much in the construction industry to connect some of the real technological advancements and advancements in our industry to what's actually happening on the ground, right? That complicates things. So does climate, so do a number of, any number of other factors. Seismic performance, right? Influences what we can and can't do. So the construction industry and the AEC industry as a whole is a complex beast, if you will. And at RDH, really what we're striving to do is to create that middle ground, that connector between what's happening on both ends of our industry.
So as an envelope practitioner or specialist, how do you, let's say an owner really values your opinion and service upfront early on in schematic design and design development, but he says, I don't need the CA services. We have boots on the ground. The subs can do their own internal QA, QC. What happens when you get that disconnect? And I'm going to like this answer.
Well, I'm at the forefront of that issue because, as a structural engineer, in glazing industry, they don't want us at the job site. And so the number of issues that come with it, or the number of issues that are not discovered for years to come because there were no eyes on the installation and, the professional who understands where the setting blocks need to be, where, how do you install the glass? How the adjustments and the whether the joints are appropriately sized as per drawings, etc. None of that is being checked, right? And so the control quality assurance kind of goes to a dumpster, and so we the owners end up carrying the ball, but that's how that part of the industry is driven. I mean, in terms of what you were talking about, I would say that on the West Coast, and especially in the southern part of the West Coast, there's a common myth that it doesn't rain in California. Well, the truth is it rains a lot. And so, the failures of the buildings is the proof of that. And so, climate change, performance for moisture and air, that still is the driving factors in our industry.
there's so many projects that we work on where we get that involvement early on, and it really is, some folks just like to learn their lessons the hard way, and the connection all the way from feasibility studies, to a grand opening. There's a lot of opportunity for things to go wrong there, and so we've got lots of clients who engaged us initially, sort of sent us away during even design and construction. Only to come back on the next project and say, you know what, we should have worked with you through the full course of the project. And really, that's how we've developed our services, recognizing that, there's a lot of firms, I think specialize, and there's a need for that, right? That say, like, this is when we get involved and this is what we do. We've sort of taken a different tack here to say, we want to be involved all the way from entitlements through operation, right? We want those owners to call us when something's not functioning properly. We want to be able to train the maintenance folks in how to operate their building and how to maintain their building. We want to be with the design team and the owners as they make decisions that impact the risk that they're going to take when they're in the operation phase of their building. So it's really about looking at a full building, the full life cycles of buildings. That's important to us.
How do you think about, you just made the comment about rain in California, and as climates are evolving and changes are happening, we could either go from the material standpoint or the climate standpoint, but things are changing, right? And so your baseline assumptions and decisions evolve. And so you're trying to be this expert or specialist to designers or owners and inform them, but you also need to focus on continuous education internally to make sure you're staying up to date with what changes are happening.
Right.
So is that a stress internally to stay on top of changes that are happening, especially, what we were having a conversation about in the hallway, material changes in fenestration and all of that, staying on top of not only where are we today, but where are we going to be in 3 years?
I think absolutely. I mean, it is, it's difficult to, it has always been, at least in my 30-year career, it's always been difficult to bring, say, a new hire in and sort of get them to understand what it is that we do, right, as a consulting business. It's always been complicated, and I've said this for a long time. I mean, just the avalanche of materials, new techniques, new methods that are coming at you. And that's not just building enclosure. I mean, I would say that's civil engineering. I would put it in a bucket, all civil engineering. I mean, there's so many new techniques and methods and materials that you have to become used to. So, I think one of the reasons that I'm here is that this company has really put a lot of stock into developing a training and publications group, which serves both internally and externally. So we serve clients like manufacturers, fabricators. We even get involved with, research that's funded by folks like the Pankow Foundation, right? That helps us communicate to our clients outwardly, and helps us inform them, but it also helps us inform internally as well. And so we're constantly looking for, ways that we can get that information across both of those lines, right, internally and externally, because we recognize the next generation of consultants, they're going to have to be a lot smarter than this guy. And they're going to have a lot, there's going to be a lot different information coming out that they're going to need to process and use on an everyday basis.
Well, I mean, it's sort of, from our conversations, it sounds like a thematic core value is continuous education and educating not only clients, but internally within the organization, and just having that spread throughout.
Yeah, and we do that all the time. I mean, you were talking about the climate change and what it does. Like, one of the bigger lessons of the last 5-10 years are the fires on the West Coast in California, in Oregon, in Washington, and even in BC. Some of that experience in BC especially was valuable when they did some testing, and they realized that a lot of the detailing that we use on the exterior envelope with exterior insulation and such can be very effective for fire resistance of the building, for fire resilience. And so that information moving from one office to all the rest of the employees is super important.
I think it's also critical. I think that's a great example. I mean, another example I think of is, as more and more jurisdictions and codes, sort of advance energy performance, it gets more complicated. And, I recently was telling somebody about, we went to New York City and we're talking to an architect there, and the CM and their subs, and it was really just about piling more insulation on to create, a passive house, a multifamily passive house. And we know from lots of experience that it's not just about piling on insulation, but where to look for thermal bridging at window perimeters and window to wall ratios and building orientation, and how you can start to think about those things and make significant changes that optimize insulation. I mean, we've got projects in Buffalo, in Boston, where we can get 3 inches of insulation, and people are shocked, right? They're like, this is a passive house. We can do this with 3 inches of insulation. Yes, with some consideration. And so we really, want to get that message out, because those are hurdles that developers and other stakeholders really sort of just throw up and say, well, we can't do this. We can't make better performing buildings because it's too expensive. It's too much insulation. It's eating into the wall, into the floor area, all of these things. And we need an industry that's ready to buck those sort of misconceptions.
I remember having Luke on 2 years ago talking about every inch you save is more leasable or rentable space. And so that's the value add.
Yeah, that's the value add. Yeah.
Thanks for coming on, guys. Really enjoyed this.
Great. Thanks, Adrian.
Michael, welcome on the podcast. And just coming fresh off your speech.
Thank you.
We got Sile on the floor here, or on the table here rather. And I think everybody knows the reputation, but I'll let you communicate it, because I think what Sile tries to represent in the market and shows through the work product is trying to be the exception. Would you agree?
I couldn't agree more. If everyone of our project is a one-off, is a unique, and we are not into repetitions. And I can only think of one project that we did 3 times in the same location, and there's a reason for that. Every single project is a custom made for a client, a designer, an engineer coming to us and say, can we do this? And they don't come to us to do a repetition or a slight modification of something that they have done. They come to us to invent something new that has not been done. And I think this is the niche in building construction where we feel most at home, and being involved early in developing concepts and trying these concepts, engineering these concepts, testing these concepts. This is what Sale stands for. And in addition to that, I want to say that we are project driven. We are not market driven. So we go after each individual project, wherever it might be. This is what's driving us.
So do you think, from a branding perspective, is that the message? Is it the end user appreciates the level of service when it comes to design assist, design build, hand holding as they're working through a concept? Or is it that an architect has dreamt something up that just nobody else can do it, and you're just forced into the room?
It is a combination of both. More on the former, sometimes on the latter side. But this type of interaction, seeking somebody who can realize a dream, is what we are often being asked to participate. And it might start with the idea, not even a sketch. Can we do this? Have you thought about that? Can we come together and even do an early design assist? This industry is about design assist. It has become known as the tool for owners and for architects, for engineers to work with, to bring the facade people on board early. And probably I have created this idea of an early design assist myself in a project that we have been asked to participate that had nothing than a 3D image and nothing else. And so developing the concept, how could this building, a private building in this instance, even look like, is what I had the honor and the pleasure to be part of. It is rewarding. I think rewarding is the right word, to be involved, being asked for advice early on to create something that has never been done before.
If you go to certain areas of Europe or different parts of the world, they're performance driven. Sometimes you could say sustainability driven. It might be a cultural thing. It might be government incentives. It might be a taste for a certain type of architecture. What do you think this market is driven by?
Doing the extraordinary, living dreams. And I think this is, from my humble experience, the best definition of, or the best difference, the best description of a difference between Europe, where thinking is regimented to really dream. And there's never a no. I think that's important in our work. We never say no to a crazy dream. We think about, how can we do it? How can we help this individual? How can we help this owner to build his dream?
Do you think where we're going in terms of, there's always going to be some balance between architectural aesthetic and performance, and really what's being driven now is thermal performance. We talk about it all the time. I think embodied carbon, you need to be able to do a life cycle analysis and make sure that the building's durable, maintainable, you're recyclable, you're working with sustainable materials, but more so thermal has been a constraint. I think when it comes to structural, air, water performance, it's remained rather continuous. Has that shaped your designs? In other words, would you look at Sealay's portfolio from 2010 to 2020, and then from 2020 to 2030, and is it going to look like two different companies?
Not so much different companies, but different designing. And in certain aspects, different materials. We are working in Canada as well. And the requirements, the thermal insulating requirements in Canada, for obvious reasons, are different. And so going for triple glazing, for example, is a building task that we find more often than not. Surprisingly, here in the United States, and it's a little bit sad, but there are architects, there are building tasks out there, and this is no criticism in whichever form. They still work with single glazing. Laminated glass for sure, for safety aspects or for aesthetic aspects, but still single glazing. And then I think here we can influence, we can advise, and sure enough, the owner has this task, and he determines for whatever reason that the building shall be single glazing. Canada is different, of course, and therefore triple glazing is not something that we shy away. For sure, we can provide that. And our sister company, SEDAC, as a producer of oversized, high-quality glass, is a viable partner. So triple glazing is something that we think we are going to see in future to satisfy thermal insulation requirements.
As an avid aluminum fan, or somebody to say, to find the perfect harmony of malleability, shapes forming, structural ability, be able to withstand extreme spans under high loads, how would you combat somebody that will say aluminum is not a sustainable material?
Aluminum can be recycled, and the recycling content is something that plays a role in longevity, in reusing material. Interesting enough, as you raised the question about aluminum, steel is the same thing. You can melt it in, and I will go one step further. You can reuse glass. For sure, there is glass coatings where you need to be a little bit careful and selective. But if you look at the materials, the core materials that we are using, all of them can be recycled. And I think this is part of our duty as facade contractors to think along this path and then advise clients which materials to use. And so the big three, you mentioned the aluminum, yes. I added steel, of course, and even glass. And with these three, I think we address most of the material, the bulk of the material that we are using.
What is your favorite project that you're currently working on?
There is this residential project in Florida that are kind of kept secret, if you like, seeing facades disappear entirely in the ground, and not seeing the drive systems in the walls is a building task that is fantastic. I have been involved hands-on on site in Las Vegas, speaking about big projects, extraordinary collaboration with installation crews and the tolerance requirements that I mentioned. And you need to think this the American way, where an inch in construction or 2 inches in construction is nothing. We work to tolerances of 0.02 inches for good reasons. And I think we stand out taking on the challenge to work to these tolerances and then push ourselves in design, in engineering, in fabrication, as well as in installation. And imagine installing 220 feet up in the air and still maintaining 0.02 inches in tolerances. That is a challenge that I would say that is outstanding. You don't find this every day in building construction.
Absolutely. I appreciate you telling us the Sealay story and coming on the podcast.
Thank you so much for having me. It's a pleasure to be here.
All right, we're back, and we got the I don't know what I call you guys the glazing specialists. The funny thing is we on these podcasts, and I jump right into it. We got True here on the podcast show. We talk so much about performance evolving codes and how that's impacting or influencing facade design. But you have a lot of people, global architecture firms, facade consultants that operate in many different markets. You guys are LA core, LA based predominantly, right?
Started in LA. I've done a lot of work in LA. We're national at one point, but the nature of work we do, you want to be close to it. So we were in New York, we were in Aspen, we were in a lot of, for our upscale projects or high-end res projects, we were all over the country. When we came back to just Southern California, and we do work in Nevada as well, we got into high-end commercial to supplement all that business that was out there. Because whether it was 50,000 square foot house or building, the complexity and nature of stuff that we do, you can't be too far from it.
So you're very engineering heavy based glazing contractor, not really selling standard off the shelf systems. Although I'm sure you have some component of that within the facade. You might have some atypical elevation or, soffit configuration or something in other areas, but you're brought in because it's probably something somebody else doesn't want to do.
Yeah, I would say the bulk of it is they'll look at it and they go, they'll do the head turn. They'll go, well, how do we do that? We have a real guy that unfortunately is not here with us today, and you will never find him online. He is a shadow, but
You know him, Adrian. I think you've met him before.
but he's a genius in our industry, and his name's Nicholas Clerget.
Clerget.
See. And he's just got a breadth of knowledge, and he just thinks out of the box and is able to take really hard things. And I've only been with True for about a month now, but it's been really cool to have the architects come and go, huh? And Nicholas will go, okay, and he'll just start building it just like a kid with his Lincoln logs or his little connectors or Legos. He just starts putting it together, and they go, okay, this will work. And if he doesn't find it, then David's creativity comes in and they'll build it and test it. And so I have yet to see a project that they say no to, which as a project manager, but also as coming on with them,
Which sometimes my balance sheet doesn't agree to.
yeah.
What
Not everyone can be a slam, right?
Well, what I was going to say is the implications of doing something new on every project, it's high risk. And a lot of times, I don't want to say you're experimenting. I'm sure you model things, you calc things, you test things, but there's also what happens when it's exposed to the element over the course of time, exposed to the elements over the course of time. And what happens when a piece of glass breaks? Not only do we have access, but did we source it from an area that it's going to take 27 weeks to get a replacement, or are they still in business? Are we working with a fabricator that might be giving us a lot of attention now, but all of a sudden their attention goes elsewhere? And so do you find that you've been successful having very key suppliers from sort of the framing and glass side, or do you feel like you got to dip your toes all over the place depending on the project needs?
Relationships matter. I mean, we have a global supply chain of glass. We don't think there's one fabricator that's right for every project. So depending on the project, depending on what people are looking at, we're talking to multiple fabricators in glass, probably for every project. Could be local, could be in America, could be anywhere in the world. And the new thing is with tariffs or anti-dumping rules, you kind of have to have some different options. So I would say relationships still matter for us in glass, and we're not just going anywhere.
How do you respond to the inevitable? And maybe you don't have, I'm sure you're going to say, yeah, we still do have price pressure, but is it different types of pressures operating at the highest tier of the market versus maybe more commodity end of the market where you have
everybody's got a budget. Everybody's got a budget. So we've been fortunate to have some really cool owners that have commissioned us to design things. And then we've had situations where they thought they know what they wanted in the beginning. They were really excited, and then the budget gets tapered, and we've got to figure it out a different way. We work in very high-end residential, but we also work in commercial construction. And to your point, if everything that you're doing is complex, the chances of staying in business are not very good. So we do have gravy stuff, and as you know, we're partnered with Schuco. They still exist in America, by the way, or out of Canada, but we believe in that system. We design around that system, so we've got some really high performance products as well that we sell to other glazers in the city. And then depending on the projects in high-end residential, a lot of the times we're having to do them with our own installers. So when you say experimental, 100% experimental in many cases, the team that surrounds you is really managing that risk, right? And so both Nicholas and I have a really strong engineering team behind us. We draw a lot in 3D. But like what I would say is we've got an interesting model in the respect that our installers are all in-house, they're non-union, and they know our stuff. And so not everything's perfect, but when we do make a boo-boo or a mistake, typically we can fix it because we've got we're vertically integrated in the respect that everybody's at true. It's all true.
So do you find more success, generally speaking, there's always exceptions, when you are fabricating and installing the project, or there's obviously unique challenges being just a fabricator selling to installers. And when you do sell to installers, I'm sure you're very selective and you need to vet them out and make sure that they're going to follow the installation instructions and all the quality associated with that. So is the preference to own it all yourself, or are you happy to supply material to glazing contractors?
We're supplying a lot of material to glazing contractors right now. We've got probably 4 projects in LA that are being done from what used to be a competitor that is now a partner. And it's an interesting sort of balance, but what they like about working with us is we actually do what they do as well. So if it's a new product and it's been spec'd and it's super high performance like Schuko and they've never touched it before, they can rent one of our superintendents and he can be on the site for them and he can show them exactly how it goes together. So we're delivering kind of a really comprehensive package for these guys that they're not, quite frankly, used to seeing. And so that's what overcomes the competitiveness, is the service and the value that we're bringing to these guys.
And when you're operating in the commercial space, it has to be a different level of scrutiny, or not necessarily? If you have an individual homeowner, he's looking at every single thing going in.
The scrutinies are different.
I don't know. Our craftsmanship is really high. That's one of the reasons why I made the jump, because to get back to doing big jumbo size glass, getting back to just high-end finishes, at the residential side, I'd say, because the houses are so expensive and the people that we are working with are people from the streets, not a lot of them are inherited wealth, right? They've made their money and they see the value of the Schuko product. And so that's why they call us to install it, or they come to us to build it and install it. So you have to be on your A game, because they're going to look at it, because pennies still mean something to them, which I thought it was going to be different. I thought I was going to be dealing with egos, but a lot of these guys have been really down to earth, just amazing people to talk with, even up to the people they hire for their management of the building afterwards have been really just down to earth, amazing people. So on both sides, we live our life by a 16th, right? That's what we do in the glass world. I think we're back though down to the 32nd when it comes to what we do.
And what has either stopped you, or are you flirting with at all developing your own systems? I told you he asked the hard-hitting questions.
So I don't know if you know this, but my family business is actually windows and doors in Toronto, Canada. We had not only do we manufacture windows and doors, but we invented and designed the hardware that goes inside them. We sold to numerous large-scale window and door houses in America because of the technology. So I grew up on the technology side of windows and doors. There's not that much that scares me, as long as you've got the right team and processes in place. I would say that you have to have experience when you're doing that. You got to know how to cut dies. You got to understand gaskets. You got to understand hardware. And you got to be able to train people to do it. And probably when I was a kid, I didn't think I was so fortunate, but I had a father that taught me everything I know. And I know how to do 2 things, man. We had a hobby farm, and I can do an artificial insemination on cattle, or I know Windows, and it's my whole life.
Good combination.
Love it.
So on an ending note, what is, I'll let you both answer, your favorite active project going up right now?
I mean, that's
Sarbonne? Is that how you say it? See, I'm already saying it
wrong.
wrong.
Sarbonne. Well, that's the 28-foot mullions, unsupported, no substructure.
It
So
doesn't get sexier than that.
that-
I think it's awesome.
that one's
One
pretty
solid
cool.
pane. It's going to
That
be
one's
beautiful.
I
pretty
already know
cool.
Spencer's question. He's going to ask who engineered that.
Well, that's engineered, and that meets seismic.
Yep.
And there's a gal that we use in Minnesota that's just a superstar, Rachel Schultz.
Shout out.
So thank you, Rachel, for all your support. But for the most part, when we're sending it to her, we kind of already, to a certain degree, know some parameters. You're Sorbonne, so I'm going to say
Sorry to take it from you.
no, not at all. We just got an STC 46 on a sliding door that we invented. So it's for a project I can't really talk about, but
I have a feeling I know which one.
that's
But it's
exciting.
legit.
That's exciting for us, because honestly, I don't know that anybody else has done that. But if I had to say what's super exciting, it's actually something we're not fabricating in our shop. It's a VS1 system, so shout out to Franz as well. And it's the Raising Cane's Chicken flagship at SoFi Stadium with an architect that I have worked with for years, in fact, helped me to get started. And it's got these 16-inch mullions vertically on the outside that also act as solar shades that are spanning 30 feet with 2 pieces of glass in it. And I would say that one is pretty exciting for me.
Yeah, not your typical chicken, chicken
Of
chop,
course.
man. But
Yep.
when he showed it to me when I came in, I was like,
Oh, bent, by the way. It's also bent.
oh yeah, it's also bent. It's amazing.
Yep. So guys, thanks for coming on. We'll do a follow-up episode and go on a deep dive for these projects.
Look
Great,
forward to
AJ.
it.
Nice to see you, man.
Well, Steve, it's I've been trying to get you on for a long time, and I had to fly 3,000 miles to get your attention. But super
Well, I
happy
spent
you're here.
2 hours in traffic this morning to get here. So,
Well, that's probably normal for you out here, isn't it?
well, I guess it is. I'm just new to the area, so it's a bit of a difference for me.
So we, in the podcast, we've talked a lot about evolving energy codes, and we had Nick Bagatellos on, who was one of my first guests, talking about the advent of low E in California and how that kind of changed the game. So you've been focused on window performance for decades. Do you finally feel like the codes are evolving to a place where they need to be?
They're evolving, but I'm not sure they're where they need to be. And I think to some extent the codes, which is, the problem with the codes is that code compliant building is the worst building you're legally allowed to build, right? So and I'm not sure that that's what we should be shooting for. They bring up the bottom, which is important, and they make sure that the mass market supplies a product that's going to work reasonably well. These days, I'm more interested in the people who are going beyond code, above code, and are trying out new things, and sort of the leaders, which will eventually become code 5 or 10 or 15 years later.
Do you think you can, at some point, sort of extrapolate what we see this revision or upgraded code every 3 years or whatever the cycle is, and we can sit here and anticipate where it'll be in 3 or 6 or 9 years? Or do you think there's going to be other governing factors once we get to a point? Because we were in Seattle last month, and it's getting to the point where, have we driven U values down too low? And if we start getting down to a 0.26, 0.24 whole window U factor, it's like, are we starting to see negative consequences in terms of embodied carbon implications and weight of the structure and so forth? So in trying to drive up performance, we're sitting here in Southern California where you have other governing factors like mitigating solar heat gain. But people just think energy code U value and code compliance. So do you think there's other metrics we could be focusing on?
Yeah, there certainly are. In some areas, you always want to improve. You've heard of Moore's law in electronics, right? You double the efficiency of the output of chips forever. It just keeps going. I wrote a paper actually about Moore's law for Windows for the U factor. And the reality is you don't have to double it forever. We're now about R4 center glass. When you get to R8 and maybe a little bit beyond that, you're pretty much as far along as you need to be in order to get to what I call a zero energy window. So one of the challenges would be to say, well, how far do you want to get? Well, you want to get to the point where the energy impacts are zero or net zero approximately, and then you want to deal with comfort. And those may be a little bit different. It may be that you want to go further for comfort than you do for energy. But there are numbers like R10 to 15. You don't need to get to an R30, 40, 50, 60 window. There's just no added benefit. And then, of course, if you bring in climates like Los Angeles, you want to start paying attention to, or not just start, but have already paid attention to solar heat gain and all the other factors. Solar heat gain is relatively easy to tune or retune for any window package, any glass package. You just pick the right coatings and you can get there. The U factor is much more dependent on what the makeup of the window is, how many layers you have, what's between the layers in terms of coatings and gases or vacuum and things like that.
Well, it's ironically, everybody sits here and maybe these are like catchphrasey. I'm kind of throwing a little humor into here, but they say, 80% of existing buildings are single pane glazing. And I'm like, is it? Because, I live in New York and I go to Boston a lot. I'm like, I don't see a lot of that. But in the hotel we're in right now, it's single glazing. Yeah. And funny enough, I think they put a window film or tint on it, probably to mitigate solar gain. And I don't know if that's common practice here, but slap on a film that'll give us a few more years and a little more occupant comfort.
So you're also talking about the difference now between new construction and existing, right? So we have the numbers. I don't recall them off the top of my head, but the numbers of single and double and all that do vary markedly with climate. But if you go back and look at history here, most buildings were single glazed up until about the 50s or 60s or maybe 70s. Double glazing started to ramp up in the early 70s. I joined Berkeley Lab in the mid 70s, and the market share of double glazing was fairly low. But within about 20 years, it was up to 60, 70, 80%. Low E started then as well, right? And it started off in the early 80s. I mean, the R&D was done in the late 70s, but hit the market in early 80s. Again, I don't have the numbers off the top of my head, but in about 10 to 15 years, it got about 25% of the market, and then 15 or 20 years later, it got 80 or 90% of the market, basically saturated, right? So your standard product now is low E double glaze, probably argon filled. So those changes happen over time. If you look at existing stock, which you were alluding to, then you've got the legacy buildings and all that old single and double glazing, and then you get into the practical issue of, can you retrofit all those? And you either replace them, in which case you're looking at new window properties and what they would do, or for a lot of reasons, historic and cost-wise, you may not want to replace them. You may want to add to them or treat them or improve them. And the good news there is there's lots of good opportunity for secondary windows that can be added to the existing window and at faster and cheaper and give you performance, which is almost as good as doing a brand new window to start with. So more and more options these days.
It's funny. I started my career in the sort of very high-end unitized custom curtain wall world. Your enclosed beds and spermas. And as a young kid or engineer, you learn that for years and you think this is this is the way buildings are built. Then I went to the window side of things and the contracting side of things, and it opened my eyes. And especially now, I've realized for so many years, I've pushed this notion of you got to replace the windows. You got to replace your glazing, whether you have condensation or failed IGUs or fogged IGUs, or just an IGU that you have argon seepage and you're basically getting minimal performance, or you have non-thermally broken frames. So you're going to get condensation, probably getting air infiltration at your interface condition. But the world doesn't live in this sort of la-la land where every building owner can afford true window replacement. Right. So you got to look at these alternate means of you got to start with what's the goal? Are we looking to reduce operational energy costs? Are we looking to attract a higher quality tenant? Is occupant comfort a driving factor? So like you said, maybe we need to focus a little more on these alternate solutions, films, secondary inserts, more efficient glass replacement, because your comment about, we don't need an R15 window to solve our issues or solve our problems. I think there's this notion that like aluminum is stretched as far as it can go, and now we need to look at alternate materials. But, it sounds like the biggest opportunity here is in the existing building market, and finding means of upgrading the envelope without it being so daunting from a financial investment perspective.
The new construction and existing markets are both important, and for a variety of different reasons. For example, in the existing market, everyone's crazy about heat pumps these days, right? If you're going to put heat pumps in old buildings with single glazing, it's crazy not to think about doing something with the window load. So there are cases where you want to focus attention on existing buildings, or other cases in new construction, since the marginal cost of going to better glazing is much smaller there. You don't have the replacement part that you do with existing. You want to be pushing there as well. So I think it's important to be pushing on both sides. Now, the things that you would do in each case are going to be different, and that depends on all kinds of issues. It depends on climate, depends on building age, it depends on, as you're alluding to, are there thermal loss issues? Are there air leakage issues? Are there solar gain issues? Is it comfort? Is it condensation? The answer is usually it's many of those, right? And one of the good things is, in terms of replacement, is you can solve many of them at the same time. You can make the window less leaky. You can make sure that your new glazing has maybe new films or coatings on it. And so you can solve the U factor problem, the air leakage problem, and the solar gain problem at the same time, or at least partly address them. When I say solve, it may not go all the way, but that's going to, and then the other issue of whether you go to secondary glazing, which can be added quickly and easily without, tearing the place down and moving people out and all that, versus a complete facade retrofit where you may have to make big changes in terms of the interior of the building. So those are factors that come into play as well.
Have you seen a large, use case for reglazing in the sense of upgrading your glazing to a super performer? Consider thin triple, thin quad, or VIG, and leaving the frame in place. Of course, there's going to be individual case studies, but do you think at a wider scale that can be a real methodology to really upgrade your buildings? Are these frames, for the most part, salvageable?
I think it depends, and I think it depends again on what climate you're in, and then what the issues are. If the issues are overall energy use, and for example, you have large windows, so you've got a lot of glass area and relatively small sash and frame, then maybe you go one way. If you've got smaller windows, old double hungs in old buildings where there's a fair amount of frame versus glass, then you may want to really do something about the frame as well. Otherwise, the overall effect you're going to get by improving the glazing is going to be much smaller. I mean, the other thing to think about is if you go to a glazing retrofit, maybe there's some, and I don't know exactly what's going on in this space, but maybe there's some other simple frame retrofit where you can add some type of extrusion to the frame to cut down on the heat transfer and therefore the condensation in an existing metal frame. To some extent, you've got to tailor the solution to the details of what's out there, which means you probably need to involve some engineers and some time and money to do that, which of course is an obstacle to changing things. It would be nice if you could just say there's one thing to do and this is it, and that's really not the case here. The other little thing we haven't talked about too is orientation. Even in the same building, you might have a southwest facing facade where there's a big solar gain problem, and a north facade where you don't have to worry about that. So lots of things to consider. The good news is there are solutions for all of them. Technically, there are solutions for all of them. Financially, there are solutions, but some are going to pop to the top more rapidly than others.
I had a electrochromic specialist on previously and talking about, people say if all four facades look the same, you're certainly missing out on performance optimization or efficiencies. I don't want to go into too long of specifics. We're going to tease the next episode with Steve to go into specifics, but one of your inventions is this concept of using a thin triple with what's known as, or not known, probably not known to most, that you can use an exorbitantly thinner center light, whether it's one or two, in the center cavity that might not be load bearing and get above and beyond performance above your standard criteria. So What was sort of the brainchild of that, the aha moment where you woke up in the middle of the night and thought of it?
So we actually have a patent from about 1990 on that. And where that came from was, we talked before that we talked about bringing Low E into the market in the 80s. And after that, the question was, well, how much further can you push the window? The answer was, if you just stuck with double glazing, the best Low E in the world and the best gas only got you up to this point here. You had to go to a triple. And once you go to a triple, then we started thinking about, well, how would you optimize that? And you still need Low E. We were worried about weight, so we came up with the idea of having a very thin center pane that was very, very thin glass, or it could be thin plastic. And thin plastic actually existed in the market, the heat mirror product at the time. That was a great product thermally. There were some challenges, I think, in terms of the fact that plastic won't last forever. There were some stretching fabrication issues involved with it. But the thin glass concept, that made perfectly good sense, right? There was only one major problem. There was no thin glass out there, right? You could get a microscope slide. I think we built an original prototype with glass from a microscope slide factory. But so that got set aside. There was some other optimization in terms of coatings and dimensions and all that. So one of the other issues was, if you're going to go to a triple and you want to keep the width relatively narrow, you wanted to go from your classic argon gas to krypton. That lets you put the entire package in about 1 inch. And if you actually go to a thin quad, which is 2 layers of thin glass, 1 to 1.25 inches, and you're getting up in the R15 center glass range. So the problem was there was no glass, right? So that was 1990-ish. About 10 years later, we went back and looked at it and played with other thin rigid plastics and played with other ways of looking at it. You could get the performance you wanted, you just couldn't find products that would actually do it right. And then, of course, we had, where's my cell phone? you started with cell phone glass, which was ideal, but when you looked at the size and cost of that, the size was much too small, right? And the cost was much too high. So it was still a neat concept, but it wasn't going to go anywhere. So it wasn't until we really got to the flat screen television era. Now all of a sudden you're making units that are meter by a meter roughly, right? And it turns out I looked at the market about 5 to 10 years ago. There was as much thin flat glass going into televisions in U.S. homes as there were windows. About 50, in really round numbers, 50 million windows a year sold to homes, and 50 million TVs each year sold into homes. So we were delivering huge amounts of relatively large flat glass into a house. I mean, the average size of a TV these days isn't much smaller than your average size of a residential window. So the problem was it wasn't coming from the window companies, it was coming from the electronics guys and all that. So, but that was the good news, because it means that people know how to make it, they know how to cut it, they know how to clean it, they know how to handle it, process it, and all that. And the early response from the window company was, this is too complicated. We try to cut thin glass the same way we cut 1/8 inch or 1/4 inch glass, it breaks. Well, yeah, but there are other people that know how to do it without making it break. About 5 years ago, we started working with a few companies, window companies, to say, let's try and solve these problems. And at the same time, the Cornings of the world and the NSGs that are making thin glass were making larger and larger units at lower and lower cost. So those converged a couple of years ago. Oh, and then the third piece of this was, if you assemble these units by hand, which you can perfectly do, lots of windows or lots of IGUs are assembled by hand, but the really cheaper, well, I think lower cost and more efficient way of doing it is in an automated line. And there were great automated IG lines out there that up until recently only handled standard thickness glass. But again, the companies that make those lines have, in the last year or two, have come up with ways of handling thin glass. So now you can basically make whatever it is, a unit a minute, something like that, relatively large size. And it's a no-brainer, and the costs are quite reasonable because the cost of thin glass has come way down. So we're excited about the opportunity. The problem now, going back to the market side, is when you talk to a building owner about, well, let's go to triple from double, to oh, it's too expensive, because every time in the past they've asked for triple, it's been double the price of double. EPA did some studies a couple of years ago in looking at upgrading Energy Star. And they looked at the market price of IGUs versus the R value or the U value. And the good news was that there were affordable units coming out with much lower U values. The bad news, or the reality was a huge range. So you can, if you try to get a quote for a triple, even a normal triple, you'll get some triples that are 1.5 times, or maybe 2.5 times the price of a double. That's basically because the company you're asking doesn't want to go to the hassle of making a triple. But if triple becomes standard, then the costs come way down.
What happens when you go to Europe?
Yeah, exactly. In fact, we're told that if you try to order a double glazed window in parts of Germany or Norway, it's more than the triple, because just the added processing cost of doing it.
Hilarious.
So the great news is that the technology fundamentally is low, well, reasonable cost, I'd say, maybe not low, but reasonable cost, incrementally only small margin above double. The performance gains are exactly what you think they would be. You can tweak the dimensions if you want by playing with the gases. You pay a little more for Krypton, but if you want to keep the IG down to 1 inch or under, you can do that. And you can, even if you want to go to a quad with 2 layers of thin glass, just out to maybe 1.25 inches, you're up in the R15 range. And at the R15 range, I mean, there's no real extra benefit to going much beyond R15. I mean, I should be careful there. If the sash and the frame are excellent, then you get more value that way. But if you've got an R3, 4, 5 frame and you're putting in R12, 15, 20 glass, there are diminishing returns for the overall.
I'm seeing amazing performance with the 7/8 inch overall light.
Yeah.
0.5 millimeter center and Krypton fill.
Yeah.
With good performing frames.
Yeah,
So
exactly.
we're going to stop there. We have a lot more to talk about, but we're going to go into specifics next time Steve's on. But thank you so much for joining us.
Pleasure.
Hi, welcome on the podcast.
Thank you. Happy to be here.
So we have a RDH takeover in LA apparently, and preparing for Heist to do your workshop. And I think the predominant focus is on structural glass challenges.
My predominant focus is on the structural side of facades for sure, but the workshop is more broad about design criteria, also including anestropy and rotor wave distortion. My small topics are climatic loads and flatness of glass and a bit of seismic movement. But yeah, the workshop is much broader, and the fun thing I feel is that the end of the workshop is really hands-on. We brought a bunch of measuring tools to actually have the people experience how to verify if what you designed and what you specified is actually delivered. And I feel that facade consultants sometimes tend to be hands-off a little bit during the later stages. And we try to really be there and be hands-on and trust but verify what's going on. And this is can be when we're working for the contractor or working for the owner or working for the architect. It doesn't matter. It really is about what's really going on rather than looking through paperwork, which is also important. But at the end of the day, we're making real things, tangible things, and there's no substitute for testing.
So glass is a really kind of sticky topic because there's this performative element to it and aesthetic element, and everybody's pushing, we have to get this performance mock-up, and they're testing weather tightness and structural durability of the envelope. But so many different layers you could take as to you want a 1x1 glass sample or 4x4 or an actual project size glass sample. And as an envelope consultant, a lot of what I would think your focus on is longevity, durability, and performance, abiding by the construction documents and project specifications. But how do you find that balance to make the architect happy and comply with their aesthetic hopes and dreams, which might be a little bit more of a gray area?
Yeah, and I think when it comes purely to the glass and the aesthetics, there are things that you can specify, like roller wave distortion or anestropy. You can measure that in the glass manufacturing plant by an Osprey machine and sort of see what the offset is or what the size of the roller wave distortions are. So there are performance indicators there when it comes to color rendering index and it comes to, okay, what do we actually like? It's going through test samples that can be just a foot by foot, 12 by 12 test samples, but making sure that you set up your viewing box right, making sure that you're not just looking in the office, but you're going to site, you're looking, goes almost without saying, but you would be surprised, looking inside of the glass to the outside and flip it around, make sure that you're at the right distance, make sure that you're at the right angle, and going through those testing or visual samples to get things like color rendering and just visual reflectivity to the architect's liking. That is before you make a decision. And then once you make a decision, you go in specification, you make sure that things like flatness under atmospheric pressures, right? So we all like to have 3/8 on the outside and 1/4 on the inside for flatness, but that's not always affordable. So then make sure that you specify the right internal pressure during manufacturing. So there are definite values that you can specify against, and samples should take care of things like color rendering and general appearance.
So in a, call it highly custom or high performing unitized curtain wall project, if you had to choose one between these three where you could have the greatest impact, do you want physical boots on the ground in the glass fabricator's facility, in the unitized curtain wall fabricator's facility, or on a construction site before the units are installed?
That depends on what is most likely to go wrong. So if it's really a highly customized unit and the glass is relatively standard, then I would like to go see the assembly of the unit by the glazing or the curtain wall fabricator. If it's all glass, I want to go to the glazing manufacturer or the fabricator, actually. So go see how the IGU units are made or the lamination and go check there. If it's about installation tolerances, and we we all have a really large museum where tolerances are a thing, right? So then I want to be on site. So it highly depends on what's most likely to go wrong. And everything else being equal, we would want to be everywhere. But if you have to prioritize the thing that has the most impact and is the most likely to pose a risk, it's to a large degree de-risking, and for everybody, right? Owner, design team, contractor, end client, for everybody.
And the reality is, I'm sure you want to have a presence or impact on all those stages throughout CA, but it's not a reality on most or all projects. So if you are heavily involved in early schematic or design stage and your scope tapers off, what protocols can you put in place, maybe helping the fabricator put together a quality control test in terms of, I mean, the same things that come up over and over again, PIB continuity, low edge coding deletion, like things that they might not be checking internally, but that you can put in place, or expectations you could set where you can check those auditing documents later after the fact.
Yeah, and I would say for those things, it's really the specifications, the written documents, because you can make a drawing and say edge delete, but what does that actually mean, right? So for controlling the quality, ultimately it's the person making it that controls the quality, right? And we should be aware of that as designers, as in, yeah, on paper it all looks great, but how do we work together between everybody to make sure that it's not just an idea, but that it's a reality?
On a finishing note, what is one thing that you wish more IG fabricators implemented within their process or protocol that isn't business as usual today, but became business as usual in 3 to 5 years from now?
Fabricator specifically, the durability of the edge seals is number one, if it's an IGU. And the other thing is making sure that the glass that you're getting has been thoroughly checked before you put it in an IGU.
Well, great conversation. I really appreciate you coming on, and I'm looking forward to the workshop.
Fantastic. Thank you so much for having me, and looking forward to seeing you at the workshop.
I didn't think we'd get I didn't think we'd get an industry celebrity on the podcast today.
No way.
What are you doing in LA?
I'm in LA for the Facades Plus conference, obviously over here in LA, supporting my colleague Patrick Elmore, who is on the panel talking about glass recycling in the architectural glass industry.
So you're not new to the glass world, although you're not new to the glazing world.
No.
But somewhat new to the glass world.
Well, it's a little bit of both, and put it in context. I've come full circle in my career. We've known each other for a long time, and to kind of bring the whole kind of story together, as I started off as a glazing contractor. I actually bought glass, so it was one of my first tasks to do a glass takeoff and actually put an order in for glass many moons ago, many moons ago. And now just progressed through the whole value chain and the whole process of the glass and glazing world. And now I have the honor of doing something really fun and impactful by taking glass that I used to put orders in and buy, and not literally, but figuratively, and be able to reclaim that, avoid landfill, and reintroduce it to other useful purposes and forms.
So help people understand, and help me understand as well. You know, we talk about life cycle analysis and sustainability and reuse of materials,
right,
for longevity. Obviously, it seems like a very focal theme in all these Facade Plus shows as of late in Seattle and Boston and San Francisco.
Right.
And I think more informed design decisions are made at this sort of upper echelon tier of the facade space, where you do have this level of attention and focus from higher level design teams, more sophisticated envelope consultants,
right,
guiding suppliers with a willingness to want to go above and beyond from an R&D standpoint.
Right.
But you know this, and there is the reality of what actually goes on a day-to-day basis in this business. And so, we were talking about yesterday how aluminum can still be recycled and a sustainable material,
right,
steel and so forth. But what happens when you put a coating on a piece of glass, and how does that impact the recyclability element to it.
It's been a long held, I think, industry myth that glass that has been coated or glass that is insulated or glass that has laminated, any high degree of post-processing on a typical piece of glass, even heat treating, renders it to be less recyclable. And I think at this point in time, nothing could be further from the truth, because that's actually what we do. We have the capability of being able to take that glass and being able to recycle it and finding and identifying other outlets for that material. So in short, architectural glass in general can be recyclable, and it's the act of adding coatings. It's a matter of just knowing that the coatings exist there and being able to work with downstream customers to ensure that they're comfortable and that that it falls within a specification range from them. I think what's more unique and novel about particularly what we're doing today, because there are a lot of other glass recyclers out there. I won't claim that we're the only ones, but what sets us apart is that we're able and we're willing and able to take insulated glass and laminated glass and be able to separate all the components and be able to segregate the glass for its own downstream markets, and be able to, if it's a metal spacer, be able to recycle those and be able to separate the glass from plastic laminates as well, whether it be PVB, SG, even EVA.
Wow! So you could take apart a laminated piece of glass.
Absolutely. It's a developed process that was developed by our CEO and our president, Jeremiah and Patrick, respectively. That whole process was developed out of a single customer making the very simple request: how can I avoid landfilling my laminated glass? And it started with a small request, and it transitioned into a mission. And the mission, I'd like to say, at least the first part of the mission is accomplished.
So I'm going to ask the hard-hitting question: why do people not know more about it? And maybe this is why you're here today, and this is part of the journey.
It's absolutely part of the journey. It's part of why I'm here today. It's part of why I was at New York as well for the same event that was earlier this year. It's about communicating and sharing with the entire value chain. It's not just focusing on one part of it. The entire value chain needs to know that this service and this opportunity is available, because glass, like aluminum, is infinitely recyclable. We just need to put the infrastructure in place and be able to have people embrace the infrastructure and be able to then grow it and then take it to the next level. But as you know, recycling is going to be hyper local, right? Because at some point in time, transportation and transportation costs and logistics and all the logistics associated with them are going to be a significant lift. And when that lift starts, interfering with the ease of operation or the ease of just the act of recycling, and we see it in our everyday lives, right? If it's hard as general consumers, we're not going to do it. It exists in the B2B space as well. So we're just focusing on locations where we have that opportunity to kind of get that critical mass. New York is one of those locations, which is why we're then. And as Patrick shared yesterday, we're really looking seriously at the West Coast, and certainly open to talking to anybody who wants to express interest in supporting the movement and being able to help us put either logistics together or line up projects or line up fabricators who would be interested in participating in the program. It all starts with a conversation. We take it from there.
So, something we were talking about in the hallway is spreading awareness about what happens in the industry. But this specifically, I don't know how much, is proprietary or not. What's the best way for people to get more visibility on the process, and how? I want to say how you guys are doing it, what you're doing, and as much specifics as they can get their hands on.
As much interface with the industry and the value chain as possible. Infinite and myself specifically were very active at the National Glass Association. National Glass Association, in conjunction with the Aluminum Extruders Council, is very generous in supporting a research project on the end of life of facade components, specifically aluminum glass. And we are happy to be involved in that research project, where we've identified one project where we're going to track that's a project in the Minnesota area that is being demolished. and we have the opportunity to record and document the deglazing and recovery of glass and aluminum on those projects. So we're actually tracking that. We look forward to be able to share those results with the industry, and to really showcase that, one, this can be done. Two, it's not as hard as everybody thinks it is. And three, it doesn't come at an extraordinary, price tag that makes it insurmountable or a difficult discussion to have within a project team.
Stan, thanks for coming on. Super informative, and I think we need to continue this conversation to go more into specifics than this little snip. But you got a workshop to run too, so thanks for coming on and had fun.
Appreciate it. Thanks a lot. I really enjoyed being on your podcast.